In this video, we're going to be looking at atoms and what they're made out of. So to start with, we need to kind of get an idea of what are the different pieces of an atom. So let's go ahead and zoom in here. We've got three parts of an atom. The first part is called a proton. And protons are positive, and then they have a mass of 1 AMU. Okay, what AMU stands for, again, what we learned in class is that they stand for 1 atomic mass unit. Okay, and remember when we talked about atoms are so small that we have to have their own relative measurement system. And so basically what scientists decided was that the mass of an AMU is going to be equal to the mass of a proton or a neutron, because they're the same. So again, protons are positive and they have a mass of 1 AMU. And then neutrons are neutral, okay, which means they basically have a charge of 0. And then they also have a mass of 1 AMU. And then we have electrons, and electrons are the little teeny tiny ones on the outside that are negatively charged, and they have a mass of essentially 0, okay, because they're about 2,000 times smaller than a proton or a neutron. Obviously, I can't really show you guys that to scale perfectly because otherwise we wouldn't be able to see the electron if I did that. So I'm going to use it as a small little blue circle. So if we go here and we look at our periodic table squares, we're going to go ahead and build these atoms, okay? And so when we're looking at the periodic table, there's a few pieces of information that we have to sift through. Obviously, the first one is we got to figure out, well, what element are we dealing with? So anytime we look at a periodic table, you can usually see the name of the element at the bottom part of the periodic table square, kind of down here. So hydrogen, it's got the name down at the bottom. And then we have the element symbol, which is right here. Okay, and so for hydrogen, it's just a capital H. And then the really important one that we definitely want to look at here is the atomic number, also known as the number of protons. And this is going to be super important to us when we're building these atoms. So let's go ahead and get started. Let's build a hydrogen atom. So what we're going to do is we need to start with 1 proton, because if you look at the top right corner, it says hydrogen has 1 proton. So I'm going to copy a proton. I'm going to put it down here. All right. And then if we have 1 proton, which is positively charged, then we're also going to need an electron. So let me grab an electron. There we go. All right, and so again, electrons, like we talked about in class, they go on the outside because they're really small and they move really fast. Okay. Now, right now, we have our atom, and this is a hydrogen atom. Now, you might be saying to yourself, well, we don't have any neutrons in here. You don't necessarily have to have a neutron, okay? In fact, neutrons are just kind of neutral pieces inside of that atom, and they really don't do a whole lot except for stabilize the atom. So for hydrogen, which only has 1 proton, we really don't need a neutron. Now, the bigger an atom gets, the more neutrons it's going to need to help kind of stabilize its mass. But if we really want, we can just go ahead and throw in a proton in here, or a neutron in here as well. So we'll go ahead and copy one of those and throw it in there. So this would be our atom, and if you want, we can draw ourselves a little, let's slide this in just a little bit closer, and then we can draw ourselves a small little orbit for our electron to go on around the outside of our atom, okay? And so that would be a hydrogen atom. And then we can go on to helium, okay? And the important thing that we want to be looking at here is, again, the number of protons. So if you look up in the top corner of helium, you can see, well, helium has 2 protons. So what I'm going to need is I'm going to need to copy 2 protons from up here. So 1 and 2. So now I've got 2 protons. And if I have 2 protons, we're also going to need to have 2 electrons. So let me grab those down here. And if you remember kind of what we talked about in class, you're going to remember that the electrons do not like to be close to each other, okay, because they have the same charge, and so they repel each other, all right? And so usually, again, if we have two protons and 2 electrons, we're usually going to have 2 neutrons as well. So I'll go ahead and copy down 2 neutrons to build our atom. Alright, and then if I want, I can go ahead and draw our little electron orbits. Alright, and then we got another atom. And then, let's go ahead and do one last one. We got lithium here, and if you can kind of see where this pattern's going, lithium has 3 protons. And so we're going to need to go up here and grab 3 protons. Oops, move that. We're going to need to go up here and grab 3 protons. So there's 1. Go ahead and drag it all the way down here. So that's 1, 2, and... oh, that's not what I wanted to do. There we go. Nope. 1, 2, and 3. There we go. Alright, so it's got 3 protons. Okay. And then if we have 3 positives, we also have to have 3 negatives. So let's go up and grab a few negatives. And the electrons. Put those on the outside. And again, I'm going to space them out because, again, they're the same charge and they don't like to be close to each other. And one more. Alright, so there we got our 3 electrons, okay? So we've got the essential pieces for this atom, and then now we need to go and grab our neutrons to kind of help stabilize the mass. So we'll go ahead and copy some neutrons and drag them down there. Alright, and let's just go ahead and let's just put 2 in this time, because again, we don't necessarily have to have 3 neutrons. And we'll kind of talk about that why in a video later. And so here we are. We've got another atom. This one being lithium. And again, the reason why I put 3 protons in there is because if we look at the periodic table, lithium is number 3, which means it has 3 protons. Alrighty, well, that wraps up this video. I hope it was helpful, and we'll see you later.